This week on Quality Digest Live, we talked to Morgan Palmer of ETQ about the right way to handle risk management.
That's right. Plus, we'll discover that when it comes to innovation, slow and steady wins the race. All that and more when we come back.
Today's sponsor of Quality Digest Live is Hexagon Metrology. Hexagon carries the widest range of quality brands. With an extensive support network, Hexagon is also your partner. Hexagon Metrology. We are metrology.
Welcome back to Quality Digest Live for April 26, 2013. QDL is your weekly look at who and what is making the news in the world of quality. I'm Mike Richmond, publisher of Quality Digest.
And I'm Quality Digest editor-in-chief, Dirk Ducharme. So, as far as I know, this next story basically has nothing to do with quality. Actually doesn't have anything to do with Lean or Six Sigma, and it isn't even about 3D, my favorite topic. It's just actually a cool story that we ran across.
It actually is a really cool story.
I had to call it out. It's about a device called Explorer, and it was developed by Bounce Imaging, founded by 3 MIT graduates. Basically, it's a ball about 4 inches in diameter. I think we got it. I think we got a slide for that. There we go. It's a ball about 4 inches in diameter that contains several cameras, near-infrared LEDs, and sensors. It can be thrown into a dangerous space where it captures images and data that are transmitted back to the user's mobile device. So specifically, it's a shock-absorbing shell with 6 cameras mounted around the around the outside of the ball, near-infrared LEDs that light up rooms for the cameras, and various other sensors that detect like gases, the temperature of the room, that type of thing. And the idea is that emergency workers can toss this ball into, let's say, a hazardous situation, like maybe a fire, or in the case of maybe a SWAT team, maybe into a hostage situation or into a room where they really just want to find out either visually what's going on in there, or in the case of a fire, what are the gases in there, what's the temperature, and so forth. So it's essentially a ball you just toss into a room, and all the images, basically what happens is inside the ball, the images and the photos are stitched into a panoramic just seconds after the ball is tossed into the room, and they get a wraparound panoramic around, along with the environmental data, and it's sent to their, it sends to a mobile device via Wi-Fi. Yeah. I mean, it's just like the craziest, and I don't think it's actually released yet. I mean, they have prototypes of the ball, and I've seen them in various press and that sort of thing. That's how we came across it. And I was trying to think, you know, are there really industrial applications for it? And I think this is one of those things where I think it could be. They kind of on their website, they mentioned, yeah, there could be an industrial app for it. They were more playing up more the emergency responder. But you know, you use things like called pigs, which they run down like pipelines and that sort of stuff. This could take the place of a pig, where you run it down a duct of some sort, and it gives you all the environmental information as well as images. But it's just like it's a ball. I don't know.
It's crazy.
Just crack me up.
But it is. I mean, the example that they used there was really like military personnel as well, where they need to go into a situation.
Right, and they just toss the ball around the corner,
get the data,
it goes inside, and they can see everything.
And the range is pretty far, as I recall. It's a pretty decent range.
It's kind of Wi-Fi range.
Yeah. So you can be a fair distance away and see what the heck's going on in there.
Yeah.
Really practical.
Pretty fine. Nothing to do with quality, but we thought it was cool.
Technology marches on. All right, thanks, Dirk. Okay, also in the news this week, Quality Digest Daily contributor Alan Nickel reveals why 5S is not just for manufacturing environments anymore. Nickel's article, 5S Your Digital Workspace, Carefully, which appeared in Monday's issue of Quality Digest Daily, offers an intriguing look into how the principles of 5S can be adapted for office workers. Now, the 5 S's, of course, in the English translation are sort, set, shine, standardize, and sustain. And those make perfect sense in a factory environment because it's easy to see the waste that can proliferate when tools, equipment, parts, or work in process can't be easily located. Right? I mean, if you can't find it, you know why you need to have a 5S system.
Manufacturing makes sense.
Makes a lot of sense. But now in the offices, as Nickel points out, you don't really spend that much time by organizing your pens, your paper clips, your stapler. You know, who cares, right? But
it's a good distraction.
It's a good distraction. I do it all the time. But now there's a reason for that. The reason is because your office is only the place where you sit. The place where your work happens for most of us office workers is where? It's in our computers, in our computerized
I see where
systems.
he's going with this.
So that's what he's talking about. So for most of us, the work is contained within our computer systems, and it's here that 5S, as Nickel describes it, can really be applied. Now think about it. How many times have you, or I do it all the time, had to search for a file or an email message or create workarounds for obsolete or maybe software that was improperly formatted? Applying the lessons of 5S to your computerized workspace can alleviate many, if not most, of those issues. There are reasons why these systems get so out of whack. It might be that somebody arbitrarily decided to move a set of files that are used by a large number of stakeholders. That's a big one. That happens a lot. People say, that needs to be over here. But now, if you don't tell everybody and you don't point to it, they're out of luck, right? Another common sin is the tendency to copy and modify source documents without properly identifying who made which changes, when, where, and why. That's another big one. I mean, you think about it, it's so easy to copy documents and modify documents that if you don't have a system in place for keeping track of all that stuff, you may not know what the original was. You may not know what you originally started with, which is a big problem. The processes to properly organize computerized systems are far easier to manage up front than they are to fix once things have gone awry, and that's really Nickel's point. As with any good 5S system, it's all about establishing a commonly accepted organizational structure and thereby eliminating waste, and whether that's on the shop floor or in the HR department, it's all valid. So for more information on Alan Nickel's article, 5S Your Digital Workspace Carefully, as well as the rest of the stories that Dirk and I will be covering on today's show, just click on the story links right below the player page, right down there.
That's right. Okay. Well, as industries increase in complexity and operations are becoming more and more global, the need for a high level of compliance is more critical. One of the problems, though, has been the question of how to frame all the various aspects of compliance. I mean, you can have environmental compliance, you can have social responsibility, you can have regulatory compliance, quality management system compliance, and so forth. So what is the common element that ties all of these things together? Well, we believe, and more you're hearing more and more about this, it's risk. What is the risk of non-compliance to anything? So here to talk about that is Morgan Palmer, Chief Technology Officer for ETQ. Hello, Morgan.
Hi, Dirk.
So do I have that right? Risk is the framework by which we can look at all compliance issues. I mean, it really can be used to kind of pull everything together?
Yes, that's correct. It used to be that we talked about compliance as a black and white thing. Either something was compliant or not compliant. It was conforming or not conforming. Audits were used to check on compliance. But nowadays, with the complexity of the marketplace, the complexity of organizations, the complexity of the production process, we talk about levels of compliance. And coming up with those levels is where risk management fits in. Risk management and risk assessment are tools that have been around for a long time to define a level of risk that can be applied very effectively to compliance in any area of your operations.
Now, it's interesting. You mentioned levels of compliance. I guess I've never heard anybody talk about that before. I mean, I would think you're either in compliance,
black or white.
Yes,
yes
black or white. I mean, you're
yeah.
in compliance or not. So, I mean, what do you mean by levels of compliance?
Yeah, that's a good question. What I mean by that is people are now trying to achieve an acceptable level of compliance. So you can overachieve on compliance, and people do all the time. They put too many controls in place, too much investment in all areas of their operations, and they achieve a level of compliance that is actually too much. That's why compliance has often got a bad name in terms of being a cost center that's out of control. So instead of that, if you try and achieve an acceptable level of compliance and measure all of the different aspects of your operations with risk management and risk assessment to try and understand at what level of compliance are you, what levels of risks do you have in your operations that dictate that level of compliance, you can apply a much more efficient and effective control to achieve compliance.
Okay, so you mentioned something here that it used to be, well, it still is sometimes, you know, people talk about quality or quality control or quality management being a cost center, you know, which is a bad term, right? Oh man, we're spending so much money on quality or quality control as if there's no payoff on it. And now you're saying the same issue is happening with compliance, and that the idea of compliance is becoming a cost center. How do you move away from that? I mean, is it just a matter of somehow identifying where you need to spend your resources in terms of risk and compliance?
It is. What's very interesting about risk management and risk assessment, which is part of risk management, is that it provides a language that is common to pretty much all your operations. And it's a language that senior management understands. So if you go to your senior management with the language of risk, saying that something is maybe part of your operation is at an unacceptable level of risk, and you need to apply a certain investment, a certain cost to bring yourself up to a newer, higher level of compliance to mitigate that risk, they'll understand that. And they'll also understand that you're not just trying to blanket the organization with too much compliance, if you will, but that you're taking a measured approach based on the risk assessment and the risk management process that you've applied. So in other words, we believe that risk is a way of more effectively and more efficiently and more cost effectively doing compliance, and it's a way that senior management will understand.
Yeah, it's interesting, Morgan, because we just did a story last week from our own Ryan Day talking about over-delivering on quality, and this very
tie in, right?
Yeah, very similar issue as you're talking, Morgan. But my question to you really is so how do you have those conversations? I mean, gosh, we all come out of an attitude of wanting to be over-deliver everything, quality, compliance, everything. So how do you frame the conversation with management where you say, well, listen, this is, I mean, you're not going to say good enough, but we are compliant, we don't need to go beyond that. How do they understand that risk needs to be coordinated and needs to be understood in that framework?
Well, it's pretty difficult. Really, you have to understand that risk assessment, risk management has to be a top-down initiative. There has to be an increase in awareness in the organization that doing risk assessment and talking about levels of compliance is acceptable. It can't really come from the quality manager. It has to come from the top. So there has to be an education on risk management, on risk assessment, on the tools, the techniques, and the impact of that on compliance and on quality all around the organization. However, having said that, senior management is very receptive to that type of education. They're already talking about risk when it comes to financial operations, when it comes to regulatory compliance. They're familiar with the term, they're familiar with the concepts, they understand the benefit. Often the compliance standards in all different areas, whether it's safety, quality, and environmental, are talking about risk directly. So they understand the language of risk, and they will be open to education throughout the organization to make sure that everyone's talking that language.
Okay, well, Morgan, we got to wrap it up here, but I do want to let everybody know that we're going to get more in depth on this topic, risk management, what it means, how to do it, why it should not become a cost center, and how it can actually be very important for your business. In a webinar coming up next week, next Tuesday, 11 o'clock Pacific. I believe there's a link underneath the player page out there if you want to go ahead and click on that and sign up for this webinar. Morgan's going to be the speaker on there. So, Morgan, thank you for joining us this morning.
Thank you very much.
Okay, so long.
Thanks, Morgan. We'll see you on Tuesday. Yeah, check that one out. You're hosting it with Morgan. Morgan's presenting. You're going to be hosting. And risk. We talked a lot about risk.
It's a hot topic right now.
It is, and there's good reason for it. I mean, it certainly. It certainly is and there you can see right there the more information about the webinar. Something that really we hear a lot from our users, and risk is really ending up to be a function of quality, and people that are quality managers who have grown up in quality in their organizations are being asked to assume the responsibility for risk as we go. So, if you're doing that, if you're in that position, check out the webinar. I think you'll get a good deep dive in that from Morgan and Dirk on Tuesday the 30th.
Absolutely.
All righty. Well, Dirk, I had an article this week that I wanted to cover, and the article was from Matthew May called "Let Discipline and Patience Enable Innovation." Matthew May, that appeared in Tuesday's issue of Quality Digest Daily. As you can guess from the title of this article, innovation is the theme of this piece from Matthew, and what he's talking about here is the true nature of innovation, what innovation means and what it means practically for those out there that are engaging in it. Now, we all want to be innovators. Every one of us is innovative, and we want to enjoy our innovation in our lives, but I think that maybe there's a little bit of a disconnect between how many people understand innovation and how it actually does work. What Matt says here is that the true nature of innovation is such that most people think that it's really about the Archimedes in the bathtub moment, that eureka, right? I have it, the aha moment. And that's how most people would understand what innovation is. But really what innovation is innovation is a process like anything else. It works by kind of grinding away at issues that need to apply creative solutions to. And it's a process, it's a habit. It requires a lifetime of discipline, and Deming would have called it a constancy of purpose. It's hard work. It's hard work to be innovative. And sometimes the true nature of innovation is kind of hidden behind some jargon or sloganeering. We've all heard these. Nobody wants to cannibalize their business, right? That's one you hear a lot. Real change doesn't happen until the burning platform appears. I love that one, right? And everybody's looking for the disruptive technology. All these quote marks, right? But you've heard all these things, right? As time moves along. I think the reason why those slogans happen is because they frame an image in people's mind of what innovation is or what it has to be in order for it to happen, right?
Right.
But that's not really the way it works. I mean, in my feeling about this, the truth behind these platitudes are that, you have to cannibalize your own business. Take the first one of those, cannibalization. What happens if you don't cannibalize your business?
It's same old, same old.
So, well, it is, but you know what else is going to happen? Cannibalization, people mean by that is that they're going to hurt their existing product lines because they're going to innovate and change. But you know what? If you don't do it, somebody else has done it.
Right.
You either cannibalize your business or it gets cannibalized for you. I guess it's not cannibalization, but somebody's going to eat your lunch. If you don't eat it yourself, somebody's going to eat it for you. This happens all the time.
But we were just talking about for ourselves. We were talking about this morning, some ideas we have, and we're like, are we going to?
We're going to get to that. Yeah. But one example I want to use is Kodak. Christopher and I were talking about this. We had an article a few months back in QDD about Kodak. Kodak, was the one apparently who had the idea for digital cameras 30, 40 years ago. They developed that in their labs.
That'll never fly.
They didn't develop it. You know why? Because their margins on their film were so. On their paper, on their printed stock images, pictures, was so high, they're like, we can't hurt that. We can't create a digital solution that's going to take away our 80% profit margin on printing these pictures. Well, what happened? It went away anyway. Somebody else did it. Another one, burning platform. Hey, the platform was always burning. Whether or not you feel the heat and smell it, it doesn't matter. The platform is always going to be burning. And the whole thing about disruption, disruption is a part of life. It's a part of business. So get used to it because it's all for your own good. True innovators are grinders. True innovators really are grinders, and they're never done. True innovators are never done. They are so deeply immersed in profound knowledge of their industry that they can't help but destroy and create in an endless cycle. And that's the true nature of innovation as this article talks about, as Matthew May talks about. Our story is such that we are a small company. QD, Quality Digest, we're a small company. We are innovators, I think. We try to model that behavior if we can. We're going to have a retreat. Dirk mentioned it earlier. We're having a conversation today about it with our team. We're going to have a retreat in a few weeks where we're going to get away from the office for a day and take off and look at everything we're doing and have no preconceived notions. You have to be disruptive. You have to be willing to challenge everything you're doing. And as Matthew May says in the story, you can't just change the margins, and you can't just think that you're innovating by changing a few things here and there. You have to change it all if you're going to change it at all.
Feet
you
first.
Change all of it. Yeah, absolutely. And we look at everything we do. I think we try to model that behavior. We try to look at everything that we do all the time and improve it if we can. You all out there are part of our process. You're our customers, so we encourage you all to let us know how we're doing and how we can innovate and help us get to where we need to go.
That's right. Give us some ideas. Like Mike said, we're going to be going away to offsite, one-day offsite retreat. We're going to be brainstorming all sorts of ideas, and
at the end of May,
kick them to us.
At the end of May, we're going to be doing that. Okay. All right. Well, thanks. And now I want to turn to a tech corner that we have that Dirk is going to be presenting here in a moment with an in-studio guest. This is a good one. This is from the Modal Shop. We're going to be looking at the drop test fixture model DTF2. Again, that's the Modal Shop, and Dirk is going to be joined right now by Kevin Rogers of the Modal Shop. And take it away, guys.
Well, thanks, Mike. I'm here with Kevin Rogers from the Modal Shop, as Mike said. This is an interesting piece of equipment we're going to look at today, and it's interesting because of how it tests. And this uses acoustics to test of all things. So, Kevin, welcome to the show, and tell us a little bit about what this is.
Okay. Again, this is what we call our drop test fixture, and what we do is we use it for 100% defect detection, so 100% part inspection. And the method we do it by is called resonant acoustic inspection.
Okay, and how does that work basically?
Okay, in this case what we're doing is we're going to drop the part a short distance onto the force
sensor. So it comes down the chute here, right?
Exactly.
Okay.
And as the part impacts the sensor, it begins to resonate.
Okay.
And we pick up the resonance by the microphone here that you just pointed out. And what we do is we plot that on the screen, and we're looking for shifts in the resonant frequency peaks due to things like cracks, changes in hardness level, missing features, those kind of defects.
Okay. So basically what's happening is when a metal part hits this, it rings kind of like a bell, right?
Exactly. That's
and
exactly
you're
right.
actually just measuring that frequency response, all the different nodes within that frequency response that are unique to that particular part.
Yes.
And so almost anything can change that resonant frequency.
Yes, and you know what we're using it for is to look for those defects that the customer does not want in their parts and using the resonance to find them.
So show us how this works then.
Okay. So one of the examples I have is that I have 3 parts here. These are valve spools, and I have one that is good, I have one that is cracked, and I have one that's missing this end feature, as you can see. And so what we do, these are aluminum, so we'll slide them down, they'll impact the sensor,
okay,
and we'll show the response on the screen, and we're looking for changes in those resonant frequencies compared to what we've taught it is a known good part.
Okay.
So I'll give those to you.
So I just slide these down the slide these down the chute, right?
Yes.
Okay.
So this one is the one that's cracked.
Okay.
So again, we're looking for changes in the resonant frequency. As you can see, it shifts out of the green boxes.
Okay, so in the screenshot, what we see is we see several peaks there, and those are the peaks related to that particular device that we just pinged, right?
Yes, we've taught it what should be a good response.
And I think we've got a little video of what this kind of looks like in slow motion. Chris, if you can run that. Okay, there we go. Okay, so it hits. Actually, can you run that again, Chris? And maybe you can stop that in midair, if that's possible. Or not. It just disappears. So there we go. Yeah, so basically we see it impacting the pressure transducer here, which triggers the microphone, right?
Yes, it tells the system to start.
Okay, so
taking
while
data.
this thing is then in the air, it's already bounced off, and it's in the air, now the microphone is picking up everything.
Exactly.
Okay, all right, let's run another part here. Now this is one that's missing, if we look at our gauge cam here, we can see it's missing. It's missing a bit off the end. See the difference between those there?
Exactly.
Okay, so I'm going to run this one down.
So you can see the significant shift on the screen here where those peaks do not match up to the green bands. So if it fails any one of those green bands, the part will be deemed defective.
And this obviously is the good one. We run that, sure enough and if we look at the screenshot, sure enough, the peaks are right within your green bands there. Okay. All right, so what we were looking at here, this was a cracked part. Okay, so we also, we have a heat treater part, right?
Yes. So in order to switch to a different part, all I have to do is stop the program and then just load the file for the other one. And again, we've already established what is a known good part on this.
Now, how do you train a part? How do you get this to recognize what a good part is?
What we would typically do is run through, say, several hundred known good parts, those that have passed a separate inspection, and teach it and overlay that data to look for differences between the known good and the known bad.
Okay, so you just run several hundred parts or whatever. Okay,
and typically we have some defect examples that we'd run through there too. Okay. So I loaded the other file for the washers, and I just hit start. And what I have here are 2 washers, and here I'll show you the washers. You can't tell by eye which is which, but I have 2 washers that are of a proper heat treating level, and I have 2 that are not.
Okay.
And they've been
visually
overly heat treated, actually.
Okay. So I'm looking at these, and I can't see a difference between them.
Okay. So I will give these to you, and the properly heat treated ones will go to the good side, and the improperly will
So I'll
deviate.
just roll this down the chute here. So that obviously was the good one. All right. And we'll take another one. And that was a good one. So that must mean I've got 2 bad ones left here. I'm pretty smart that way. All right.
So again, you can see on the screen where we have a significant shift in the resonant frequencies, and again, if we fail any one of those, we fail the part.
All right. And so the last one obviously is going to fail too. Okay. So is people who use your equipment, are they normally using it for sorting, or are they using it for pass-fail on parts? Typically, how is this being used?
Typically, it's for defect detection.
Okay.
We do have the ability to separate parts. I actually have an example here where sometimes materials get mixed up, sometimes parts get mixed up, and it's hard to identify one from the other. So in this case, I brought an example of an application that works very well. I have several 8mm screws here, and some are 20 millimeters long, some are 16 millimeters long. If they became mixed, we could run them through the machine and look at the signature of the part and teach it that I want these to go this direction to the pass side, these to go to the fail side.
Okay. Now, actually, speaking of sorting, you told me an interesting story yesterday when you came up about you had a customer that called you. They were pretty frantic because they had an expensive mistake. Tell us about that.
Yes, we had a customer who makes bearings, and they had mixed approximately 40,000 of bearing type A and bearing type B. They were the identical dimensions and appearance, but they were two different materials.
Okay.
So rather than scrap the whole lot, they used our system to separate the two types of parts because they had different resonant signatures.
And what do these bearings cost each?
About $2 a piece.
Okay, so this is 80 grand of scrap.
Yes.
Okay, so they just took them and
ran them through the machine. We had, say, a 50 that we ran through of a known type, and then any deviation outside of that would have been the other type.
So they just ran them through, and they were able to sort them out and save the entire lot. Okay. Mm-hmm. But how quickly does this run parts?
This one will run parts about 1 per second.
Okay. All right. Actually, go ahead and bring up the program for sorting that. We got a little bit of time here. Let's take
Sure. I will give these to you.
All right.
And then again, it's once you've established the criteria, you just hit File, Open Project. I'll save that.
All right. So this is really easy to use. I mean, pretty much any operator, once this has been trained, any operator can bring this thing up, and just a matter of just feeding the parts through, right? Okay.
Exactly.
All right. So I'm just kind of randomly. Oops. Sorry.
That's okay.
All right. So that one failed. So that was obviously a short one then.
Yes. So in this case, we've got the 16 millimeter screws going to the fail side, and we're trying to pick out the 20 millimeter screws.
And that's a short one. Okay, there it goes. All right. I can see them as I'm, so this one should pass. And it looks like this one should pass. Sure enough, and that looks like a shorter one. So, and there's 4 millimeter difference on these, right?
Yes. Okay. So again, we're using this to sort for gross dimensional defects.
Okay. So basically what we're talking about is a drop test. Now I know that you have another machine that's similar to this for parts that you don't really want to drop. Basically it's the same thing, a conveyor belt? Mm-hmm. And what's to do, like, kind of pings them? Is that the idea?
That's exactly right. Yeah.
Ringing in glass. Okay.
People call it the ping tester.
The ping tester. Okay.
So what it does is it impacts it with an electric hammer, just slightly, and it's not going to do any damage. But it's also a 100% inspection method. So it's on a conveyor belt. The operator places the parts on the conveyor. The machine does the testing, the sorting, and pushes off the good parts and lets the bad go off the end.
We had a question come in. You can go ahead and put that up, Chris. And there we go. The question is, you mentioned heat treating. Can you detect a part that has been improperly heat treated? What we looked at here, I guess, was one that was not heat treated versus one that was. I guess they're looking at something that's been heat treated but maybe not completely?
Yes, we can find parts that have been properly heat treated. Again, what we do is take several hundred that are of the proper value, and we look for deviations outside of that. Anything that affects the mass, the stiffness, or the damping is what affects the resonant peaks. For the heat treating level, we can typically find values exceeding a Rockwell C scale of 5. So if your range was between 40 and 50, once you go above the 50, we can separate those out and below 40, for example.
Okay, that's not bad. So what's kind of the cost range on this?
This is in the low 40s.
Okay.
And then the fully automatic system would be in the low 70s.
Okay, well, Kevin Rogers, the Modal Shop, thanks for bringing this by. Interesting piece of equipment.
Thanks for having me.
Okay, sure. Back to you, Mike.
Well, there it is. Yes, the Modal Shop drop test fixture model DTF2. from the Modal Shop. Thank you, Dirk. Thank you, Kevin Rogers, for doing that. Kevin, great guy. Despite being a University of Cincinnati Bearcat fan and alumnus, great guy. Yeah, good,
despite that.
Good time. Well, I'm a Rutgers guy. Come on, I went to Rutgers. Very competitive football team. Basketball, they beat us all the time. Anyway, so good. Thank you, Kevin, for doing that. Thank you, Dirk, for showing that off as well.
Sure.
And always good tech corner. If you guys have any tech corners out there that you want to bring to us, just write us at QDL@qualitydigest.com, and we'll get them on the air for you. Okay, well, that's our show for this week. But before we go, we'd like to thank today's sponsor. Hexagon Metrology is committed to helping you control your processes, enhance the quality of your products, and increase efficiencies. They empower you to stay one step ahead of a changing world with their wide range of product offerings, nearly 200 years of expertise, and an extensive support network. Hexagon Metrology, where quality comes together. And Dirk, as you know, we're going to be at the Hexagon Live, the HXGN, Hexagon Live User Conference, coming up in a little more than a month in the fabulous MGM Grand in Las Vegas.
When you were that time, I never left. You realize we went in that building and we came out like 3 days later.
Yeah,
and never left the building.
That building is like bigger than like some towns I've been in. I mean, it's crazy. Great place, a great conference. We were there last year. We had a lot of interesting coverage last year. This year, we're going to be having a special episode of this show right here, live from Vegas. We're going to have some interviews, close-up looks at some really interesting technologies, and a whole heck of a lot more. So that's Hexagon Live in Las Vegas, June 3rd through 6th. To find out more, you can click on the banner ad just below or just to the right of the player page right down there somewhere.
That's right. And thanks again to Kevin Rogers of the Modal Shop for joining us in studio for a great tech corner, and to Morgan Palmer of ETQ for Skyping in to chat about risk management. And don't forget to sign up for the ETQ webinar on this topic, risk management, coming Tuesday, April 30th at 2 p.m. Eastern, 11 a.m. Pacific. Again, there's a registration link in Morgan's article and just beneath this screen, I hope.
Yeah, easy for you to sign up for that one. Yes.
Oh, and also, by the way, Kevin, I believe we had the wrong website for your. We didn't have it. We got it fixed. Okay, all right,
good. We're on it.
Never mind that. We fixed it.
You're on
Somebody
it.
fixed that.
Dirk,
the website
Dirk
is there. That's great.
That's right.
Possible.
Live TV, folks. But again, thank you all for being here. And you know, Dirk, I didn't mention this to you. You know, our first show. Do you remember this? Our first show, first Quality Digest Live, was April 29th, 2011. This is really our 2-year anniversary.
Oh, wow. That's
this
awesome.
is the closest show to that. So thank you all for giving us 2 years of this show. It's really...
That's right. And our audience has doubled.
Tripled, at least. Yeah, it's been great. No,
we're up to 10 now.
No, Dirk doesn't know what he's talking about. Anyway, thank you all for being there with us throughout the whole thing. It's been a great couple of years, and we look forward to many more years of QDL coming up in the future. Okay, well, thanks all for being there with us this week. We'll see you all next week for another week of QDD, and this show again next Friday. So have a great weekend, and we'll see you then.
So long.
Bye.